Okay, so that's what we were talking about on Tuesday there. Okay, those different parts of a straight line. Okay, now when we're solving the straight line that we've got on the screen, we're getting two individual points. Okay, and we're going to label them point 1 and point 2. Okay, so you can label them on the page if you want, 1 and 2. But that just lets us know where our x coordinate is going to come from and our y coordinate is going to come from when we're working out the gradient. Okay, so remember the letter m we use for gradient. The equation for that is y2 minus y1, x2 minus x1. Okay, x1, y1, x2, y2. Okay, now it doesn't matter which way round you put these points, as long as x1 and y1 come from the same point, and x2 and y2 come from the same point. Okay, so don't worry about which one you're choosing to be the first point and which one you're choosing to be the second, it still works. Okay, y2 in this case, I've got -5, y1 is 7. Okay, so take away 7. x2 is 3. And it's -1. Okay, so that will become a positive. Okay, be careful with the signs. Okay, that will become a positive. So -5, -7, -12. 3, -1 will be 3 plus 1, which will give us 4. So it'll give us a gradient of -3. Okay, now that makes sense. A negative gradient is a line going in a downward slope. Okay, a positive gradient would be a line going in an upward slope like that. Okay.
So does that mean then if visually just looking at it then and what way it's going, you would know what kind of answer it's going to come out?
Yep, you would know if it was going to be positive or negative.
Okay, I get you.
Okay, so that's the gradient. Okay, so we can take that gradient and we can put it in the position of m. So we're substituting in place of the letter m and our y equals mx plus c. We are substituting in that answer, -3. Okay, so I'm going to go on the left-hand side of the screen. Okay, and do this. Okay, so it's all on the same page. We've got y equals mx plus c. And we've worked out m to be -3, x plus c. Okay. Now we substitute in one of our points. Again, it doesn't matter which one, it will give you the same answer. Okay, so I'm just going to substitute in point 1 into this. Okay. So that's my x term and that's my y term. And I'm going to use this to substitute into that and work out or isolate our term c. Now c is where it cuts through our y-axis. So y is 7, -3 times -1 plus c. Okay, so 7, -3 times -1 would be +3 plus c. Bringing the 3 over to the other side. Equals c equals 4. Okay, so our y-intercept, this point here, is when x is 0 and y equals +4. Again, visually, I can see that makes sense. Okay, so that makes sense because the y value is above 0, so it's above the horizontal line. Okay, so that makes sense. And the y value is below this value here, that's 7. Okay, so the line is going from +7 downwards. So it's cutting the y-axis below that +7. Okay, so again, it makes sense. So without a scale to read off, okay, that answer makes sense visually. Okay, so our final answer would be y equals negative 3x plus 4. Okay, that's our equation of a straight line. Okay, so we'll do a couple more questions like that. Okay, but I just want to show you an example in which we use a fraction as a gradient as well. Okay, so there's a wee process that we just go through that. Okay. Gradient is equal to 2 over 3. And the line passes through point 5, negative 12. Okay, so it's given us a gradient this time. Okay, we're looking for our equation of a straight line, so we're looking for something in the form y equals mx plus c. Okay, so we're looking for it in that form. It gives us the value for m. Okay, remember m is our gradient. Okay, now what is missing from this is our y-intercept. Okay, but we get given a point, so we've got one point where we've got an x and y value. So we can put in what we know. We know what m is, and we've got a single point in that line, which is 5, 12. Okay, so the x value is 5, y value is 12. So we can substitute all of these terms in, and again, solve for c. Okay, so y value is negative 12. X value is 5. Plus c. Okay. Now, what we're going to do here is try and remove that fraction, okay? Or what we're going to do is try and remove that fraction. Now, that fraction's a divide. Now, when I'm trying to remove something, as long as I do the same thing to the left-hand side and the right-hand side, I can do whatever I want to that fraction or that equation. Okay, so as long as I'm consistent with what I do to the left-hand side and right-hand side, I can do whatever I want. So we're trying to remove that divide by 3. So I'm going to multiply everything on the left-hand side by 3, and I'm going to multiply everything on the right-hand side by 3. Okay. Remove the denominator. Okay, so the number on the bottom of that fraction by multiplying by the number. Okay, so remove that denominator by multiplying the left-hand side and the right-hand side of that equation by that denominator. Okay, so I'm going to multiply the left-hand side by 3, and then I'm going to do the right-hand side by 3. Okay. Okay, so I've put that right hand side in a bracket just to show it. Okay, now that right hand side, I've put everything there, and I'm going to multiply the whole thing. Now, remember when we break brackets, we multiply the outside of the bracket by every term inside it. Okay, so that 3 times -12 will give us -36. That 3 times 2/3 will just leave us with a 2. And then 3 times c will be leaving us with 3c. Okay, just tidying that up a wee bit.
How come you still include the fraction if you're taking the denominator away?
So we're just tidying it up a wee bit. To be perfectly honest, I don't know why they want to leave it. I suppose it leaves it a wee bit tidier.
Right. Okay.
That's the only reason I can think that they want to do this. But yeah,
That's fine.
okay, it leaves that. Yeah. So we're going to tidy that up to find out the value of C. Okay, so -36, moving that 10 across will leave us with 3C. Okay, so 3C and -46. Okay. Now, because I multiplied both sides by 3 and we're getting the 3C, we're going to keep that, and we're just going to keep consistency. Okay, so we're going to substitute 3C back into this format. Okay, but we've multiplied this by 3 and we've multiplied the gradient by 3 to remove that denominator. Okay, so we're going to end up with 3y equals 2x, oops, minus what we've just found for 3c, which is -46. Okay, and that's the expression, that's the equation of the straight line. Okay, so a wee bit convoluted, and I'll give you that, it's a wee bit convoluted. I don't particularly like it, all right, but it can come up that they want us to remove that fraction and leave it in that format. Light stuff going out. Okay, let's not dwell on that too much. Let's just show another example of it. Okay. Find the equation of a straight line. And the gradient is equal to -3/5. And it passes through the point of -4 and 10. Okay, our x and y. Wanting the form eventually of y equals mx plus c. Okay, but without the fraction. So we're going to put in our numbers that we know. The y value is going to be 10. Gradient -3/5 times by -4 plus c. Okay. You could make your life a wee bit easier at this stage and sort of break this first initial bracket. All right, it might look a wee bit less confusing. Okay. Now we can do that by doing -3 times the -4. Right, and that will just give us 12/5 plus c. Okay, so I've just broken that bracket, just tidying it up a wee bit. right? Make it a wee bit simpler to look at. Now we're going to remove the denominator by multiplying each side. And then we're going to solve for C. Okay, now we can flip that out. Okay, because we've multiplied it all by 5, final expression positive 38. Okay, so to remove that denominator, as long as I do the same thing to the left-hand side and the right-hand side, it works out okay. Okay, let's sort of combine the question I did at the start, the first example I did, with getting our fractions. Okay, so we are finding equation two coordinates. We get given the points, -1, -3, and 7. Right. Okay, that's our 2 points. So we're looking to find the equation from these 2 coordinate points. Okay. Again, we'll make that x1, y1, x2, y2. First thing we want to do is find the gradient. Okay, so remember, looking for y equals mx plus c. Okay, that's the form we're looking at. Okay, so we're looking for the gradient. And we don't get that equation in the exam. Okay, y2 is -9 minus -3. X2 is 7 minus -1. The 2 minuses make it a positive. So we +3. -6/8. Okay, should give us a gradient of -3/4. Okay, simplifying that down. Okay. Substituting that into our okay, going to get our y equals -3/4 x plus c. Sub in one of the points. Okay, doesn't matter which one. Okay, just point 1. The y value is -3. X value is -1. Let's see. Okay, I'll just tidy up that first bracket. -3/4 multiplied by -1 would give us +3/4. Okay. Now I'm multiplying everything by 4 to remove that denominator. Okay, so multiplying both sides, the left-hand side and the right-hand side. Bring that 3 across. On the right. Okay, because I multiplied it by 4 at this stage, I'm substituting in 4c. I'm going to write it as 4y equals, what was my fraction, -3 x minus 15. Okay, and that's the equation. Okay, particularly nasty. Oh. I'm still copying. All right, I'll let you have a go. Okay. Find the equation of the line. Okay, I'll give you time 36. Oops. Okay, I'll give you until 1/4 to have a good start at that. Okay, so remember I'm finding the gradient. Okay, and then substituting that into our equation and getting rid of the fraction. Okay, so I'll give you until 1/4. So, all right, nice one, guys. So hopefully you had a good go at that. Okay, so quickly run through that. Okay, and because we multiplied both sides, okay, we're going to end up with okay, or we don't need to write the 1. Okay, if you wrote the 1, it's absolutely fine. Okay, still mathematically correct, but in algebra we don't need to, okay? Is anyone way off?
I'm not way off, but I had like substituted in like the negative fraction in front of the x in the final equation.
Right, okay, so negative half x.
Yeah,
So you're close, you're getting there. It's just remembering that because we've multiplied both sides at this stage,
yeah,
we'll keep that up, all right?
right.
And
Oh
you'll have
yeah,
a
yeah.
fraction at that point.
Okay. Thank you.
Does the fraction need to be simplified?
Yeah,
I didn't simplify it.
you just keep it.
Yeah.
Yeah, it's still mathematically correct, but it's what they're looking for, so.
So it was on the exam.
Okay, since we've got the book and it's working, so let's have a wee look at simultaneous equations and what I mean by that. What I mean by simultaneous equations is we're going to use equations, okay, like the ones we've seen for straight line and the different ones we were solving last week, okay. The simultaneous part just tells us that there's more than one of them. All right. In our case, there's going to be 2 equations, 2 unknowns. Okay. Or what it allows us to do, okay, is find, linking it back to the last section, find the intersect two straight lines. That does not look like a lot. Okay, finding the intersect of two straight lines. So if we've got a graph, okay, we've got straight line going that way, straight line going that way, it allows us to find this coordinate. All right, that's important. All right, so it allows us to find the coordinate. So the method that I'm going to go through is elimination. Now, I've said this a few times, there's different ways of teaching different parts of this course, okay? Simultaneous equations is one of them, so you might have been taught it a different way, or your tutor, if you've got a tutor or anyone helping you, they might know a different way and they might feel more comfortable with it. If you want to do that different way, that's absolutely fine, okay? If you've got any issues with it, doing it the other way, you can still ask me a question, I won't get offended, okay? But this is the way I sort of prefer. Okay. First step then. When we get to equations, we need to put them in the same sort of form, okay? So make sure that the letter terms are on the left-hand side of the equation. Okay, so they're the left-hand side of the equal sign. Okay, and when we do examples, it will make sense, okay? But say 3x plus 2y equals 12. Okay. Okay, that's two equations. That's two equations where the letter terms okay are on the left hand side and just in numerical terms on the right hand side. That side numerical. My writing's a bit off today. Okay. Now that differs slightly from our y equals mx plus c, that format. Okay, so that's all we've done is move that x term over to the left hand side. It just makes it simpler to sort of form and eliminate as we go through. All right, so that will make more sense. Make sure the number in front of the second terms okay, second term in both equations are the same. Okay. So for those equations above, the second term would be the y term. All right, so it doesn't matter about the letter per se, okay, and I'll show you that when we go through different examples. Okay, but as long as that second term has the same number in front of it. Okay. You do that, or we achieve this. By cross multiplying. Okay. Now I'm just giving you these steps where you have them to read. Okay, and you can follow it through because it is a wee bit of a process. Okay. Sorry guys, just trying to move the board up a wee bit. Last person using it was a tiny. Okay, once you've got the second terms the same, we add or subtract vertically. Okay. Add or subtract vertically. That allows to solve for one of the unknowns. Okay, so x or y, okay, and 5. Substitute answer from step 4. To solve for other unknown. And 6, which is optional. Check answer. Okay, I'll explain that in a second. So these are 6 steps, okay, 5 or 6 steps. Okay, and I just wanted to write them down just so you had it, so you can follow through, because it is sometimes quite a lot of writing. Okay, so let's put that wee example up. Okay. Now, you'll get asked to solve. Okay, you might get asked to solve something specifically, but you get asked to solve for the unknowns. Okay, and you'll get given two equations. Okay, so that's two separate equations. Equation 1 and equation 2. Now going through our checklist, one was, are they all in line? Yep, okay, all our terms on the right side. Second one was, are the numbers in front of the second term? So in this case, the second term we've got is both y, okay, and the numbers are the same. So 5 and a 5. So the numbers in front of the second term are the same. Okay, so step 2. And then 3 is a decision that we need to make. Do we add or subtract? Okay, now whether we add or subtract is we are trying to eliminate one of the terms. We're trying to eliminate the y's in this case. So if we add these expressions together, we're going to eliminate that y, because we're going to have positive 5y, and then we're going to have to add to that negative 5y, so it will eliminate that. So we're trying to eliminate that 5y. Okay, so we're going to add both of these terms together vertically. Okay, so when we've constructed them, then when we've got equation 1 above equation 2, and all our letters are matching on the left-hand side, and the numbers are on the right-hand side, okay, and columns, we can just do that. Okay, column 1 is our x terms. 6x plus x just give us 7x. Column 2, I'll move that. Okay, column 2 we've got our y terms. Okay, so it's plus 5y, and if we do plus negative y, we're going to get 0. Okay, we're going to get nothing in there. They're eliminated. So the y terms eliminated. You don't need to write eliminated every time. Okay, you just don't need to write anything. So we've eliminated that, we've taken that out. Okay, and then our third column, we've got our 9 plus 19. Okay, and that gives us 28. The equal sign stays where it is. Okay, now when you go through this, you don't need to draw the columns and the wee add sign that I've done. I'm just doing that to make it clear. Okay, so we're left with 7x equals 28. Solving that for x, isolating it, it's a multiple on the left-hand side. So it becomes a divide on the right. 28 divided by 7 is 4. Have I lost anyone?
So is that the answer then for the intersect?
No. That, well, that'll be half your answer. So we found out the x term.
Right.
So that's the x coordinate. So if that was two straight lines,
Mhm.
Alright, that would be the x coordinate. But we need to
Okay.
find the other coordinate. So to do that, we sub our answer in, okay? So instead of writing sub into equation. And you can pick any equation, so you can pick one or two. Okay, so if I substitute that into equation one. Okay. Where I've got the letter x. Where I've got the letter x, I'm going to substitute in that number 4. So 6x means 6 multiplied by 4 plus 5y equals 9. Okay, so 24 plus 5y equals 9. 5y equals 9 minus 24. All right, I'm just going to bring this up here. So 5y equals 9 minus 24. That would give negative 15. Okay. So isolating y, negative 15, we get divided by that 5. Y would equal negative 3. Okay. So if it was a coordinate that we're looking for, the x coordinate would be 4, the y coordinate would be 3. Sorry, negative 3. Okay. That would be your answer. Now, the last thing I said, step 6. Okay, I said you can check. Okay, now you don't have to do this in the exam. If you've got a wee bit of time at the end, then you could do it. Okay, but you can substitute x equals 4 and y equals negative 3 into either of those equations and they should work. So we sub it into equation 2, which is x minus 5y equals 19. If I substitute in the term x into here and the term y into here, I should get 19. Okay, so 4 minus 5 multiplied by minus 3 would give us positive 15 equals 19. So to have 19 equals 19, which is correct. So if my answer was wrong for either x or y, then I wouldn't have the left-hand side equaling the right-hand side. Remember that equal sign just means it's balanced, just means whatever's happening on the left is happening on the right. So 19 equals 19, perfect, all right? If, for argument's sake, okay, don't copy this, if for argument's sake I've got x equals 3, okay, and y equals 7, okay, I'll do 3 minus 35, which equals minus 32, and that doesn't equal 19, so something's gone wrong. Okay, so if I had the wrong x and y, then my equation, if I substituted it back in, would not work. Okay, my left-hand side wouldn't equal the right-hand side, so something must have went wrong, and I would have to go back to the start and find my x term again, and then go through the whole process. Okay, which is a pain. Give you one more example, then we'll take a wee 10-minute break, guys, okay? Okay, so let's go through our steps. Step one is all our letter terms over on the left-hand side, yes. Okay, are the numbers in front of the second term the same? In this case, the second term for equation 1 is 5, but the second term in front of equation 2 is the number 2. Okay, so they're not the same, so we have to make them the same, and we do that by multiplying the top line by the number in front of the second term of equation 2, and the bottom line by the number in front of the second term in equation 1. Okay. And that's what I mean by cross multiply when I was writing down the process. Okay, now that multiply, we multiply everything. Okay, on left and right of equation. Okay, so everything in it, so the whole of the equation gets multiplied by that number. Okay, so equation 1 is going to be 4 times 2 is 8x plus 10y negative 14. Equation 2 is going to become 15x plus 10y equals negative 35. Okay. Now I'm seeing whether I add or multiply. Remember, I'm trying to eliminate that second term by vertically adding the two equations or subtracting the two equations. In this case, I'm going to subtract. Okay, so 8x minus 15x is going to give us minus 7x. Plus 10 minus 10 is going to give us 0. Minus 14 minus 35, so that would give us, so just taking that to one side, minus 14 minus 35 would work out as minus 14 plus 35, okay, which would give us 21. Okay, positive 21, and then we're solving for x. Okay, so quite a lot went on there. Okay, so just take a wee breather. That I've just taken to one side just to make it a wee bit clearer for me. Okay, just to make it clearer for myself. Now we're taking that x value and I'm going to substitute it into one of the equations. Okay. Let's push that forward. Okay, so simultaneous equations. If we just continue with a few more examples. Okay. We don't have to use X and Y's. Okay, we can use any letters. Now remember what letters are. They're just variables. They're just something that is a position where we can put another number. Okay, it just means a position where, right, I don't know if you keep cutting out. All right, just a position where a variable can go into. Okay, so two equations again. We're going to cross multiply again. We're going to multiply that top one by 4 and that bottom one by, there's no number written, but there's a 1 in front of that B. Okay, so that will just stay the same. That second one will just stay the same. Okay, now watching out for the sign in front of that second term. That bottom one is negative. So if we add both of these together, okay, that negative is going to, okay, eliminate that second term. Going to solve for one of them, and then substitute that into equation 1. Okay, to get 2 times 6 plus b equals 10. 12 plus b equals 10. Okay, and then if you want, you can check by substituting in 2a. Okay, as I say, it's one of these things. It's actually quite nice as a process to just flow through that. All right, so once you get good at it, once you've done a wee bit of practice with them, and you understand each step, and you're getting quite quick with it, it's actually quite a nice process to follow through. Okay, now remember, in the exam, you don't need to do this. You don't need to do the check. It is literally just a check, okay? So if you've got time at the end of the exam, if you've got a spare 10 minutes, do a wee check here and do a wee check there on a couple of different questions. That's one of them.
See how the two questions that you gave us before the wee break? The second one, I've tried to like work that out twice now, and I've checked it twice, and I can't get the answer.
Okay, let's have a wee look. Question, what's that? D. Okay, we're gonna subtract them. That's gonna give me 7x. It's gonna give me -7. Okay, I'm gonna get x equals -1. I'm gonna substitute that into, doesn't matter, so I'll substitute it into 2 just for argument's sake. Okay, so I'm getting x -1 and y equals 3. Okay, so check. Oops. So that's what I'm getting. Is that not what it shows at the back, or?
I was just getting, when I was substituting it into the 5x plus y equals -2 equation, I was getting -7 as my answer. And then when I was like trying to work it out and check it, I wasn't getting that. I was getting like -12.
This. So this bit here.
Yeah.
Okay, cool. Let's sub it into the other one then, just do the same thing. Sub into equation 1.
Now I know where I've went wrong.
No problem.
Thanks.
Okay guys, so if you are working through the booklet and you either get stuck at a question or if it doesn't match the back, and that's a really important one because for whatever reason, some questions don't match the answer at the back. All right, so if you're getting that, don't sit on it, just email me and we can go through it in class. You won't be the only one. Okay. Nice one. Right, let's do it with a couple of lines. Okay, that doesn't have to be to scale, it's just a sketch for illustration purposes, okay? Okay, so we've got 2 lines. Terribly drawn graph, but we'll go with it. All right, we've got 2 lines. No. No. I've moved that. Oh, that's not what I want to do. I've no idea how it works. Right, okay, we've got 2 lines. All right, and we're looking to find Find the point of intersection. Okay, and we're getting given the two equations. Five x equals 4y plus 22. -9. Okay, so we're getting 5x equals 4y plus 22 and 3x plus 5y equals 9. Okay, so you get a question like that. Okay, and we're looking for the point intersection. So you might get given a wee sketch there. First thing we want to do is write down our equations vertically. Okay, so one above each other. Okay, so number them. I like to number them, it makes it a wee bit simpler. So we've got 5x equals 4y plus 22. And we've got 2, which is 3x plus 5y equals -9. Now, the first thing we want to do is get all the letter terms of that first equation over to the left-hand side. Okay, so 1 is going to be rewritten as 5x minus 4y, because we've moved that whole term over, equals 22. Second expression doesn't need to change. Okay, so that's getting it in line with our first sort of process, okay, which is getting everything in a vertical, but all the letter terms on the left-hand side of that equal sign. Then I'm going to multiply that top line by 5, multiply that bottom line by 4, okay, and then we write 1 as 25x minus 20y equals 110. 12x plus 20y is equal to minus 36. And then we're trying to eliminate, okay, those two figures.
Would it be -4, not +4?
So you can do that. I don't. Okay, some people make it the same sign and then just always sort of add them together. Okay,
Right.
eliminate or sort of take them away. I prefer just leaving them the sign they are, using the numbers that are there, not the negatives and positives. Okay,
Right.
and then just adding or subtracting and making a decision at that point to eliminate them.
Right, okay.
Okay, so I'm going to say no because it changes the sign of too many of the numbers and it leads to more confusion, in my opinion. Okay, so if we add them together, you're going to get 37x. You're going to eliminate the y term and you're going to end up with 74. Okay, so x which is equal to 2. I'm gonna keep that there. Substitute x equals 2 into one of the equations. Okay, so equation 1 is fine. Okay, so 5x minus 4y equals 22. Right, what have I gone wrong there? Because 5,
22 take away 10 is 12.
5x, 22. Good shout. Where did I get minus 32? Just making stuff up. Thank you. -3. All right. Now, the reason I can pick that up and see that that was wrong, I got +8. Now, if I had 2 and +8, my coordinate would be away up here. All right, because positive in the y would be above my origin. All right, that's positive. Okay, and below the origin, I'm going to have a negative y. So if I had a positive y and I had been given that as a sketch, I can see very clearly straight away that's wrong. All right, I'm looking for a negative y and I'm looking for a positive x. All right, so my coordinate, just to finish that question off, coordinate where those lines intersect each other would be 2, -3. And that looks right as per the sketch. Okay. 2, 8 would be way off. All right. Life past 8. Okay, a couple of questions I want to go through. This is past paper and it's 2017. Question 13. All right. Question 13 is quite late on in the paper. So I thought it's going to be quite hard. All right. Again, you get given 2 lines. Okay, so in the question itself, in the past paper, you get given a wee sketch. I'm not going to do the sketch just for time. Okay, I'll just give you the equations. Dx minus y to okay, they're in the vertical. Okay, so x's are above the x, the y's are above each other, and the numbers. Okay, everything's on the right hand side or in the correct position where we want it. Okay, so it's a case of making that second term the same. Multiply by 3, multiply by 1. Add them together. 10x, the y's are eliminated, and that equals 25. Now the difficult part is here, 25 over 10 is going to give you a decimal. Now don't be put off with that when we're substituting that back in. Okay, so when we're dividing by 10, we're just moving that decimal point, so it becomes 2.5. Okay, we're going to look at top heavy fractions, okay, later on as well. So we're going to look at that a wee bit more depth, okay. But being able to turn a fraction into a decimal is an important skill as well. Okay, so maybe look back at National 4 stuff on BBC Bite Size if that's, you need to re-familiarise yourself with that, okay? But X is just going to be a decimal, okay? So don't be too put off with that. Okay, we're just going to substitute that decimal back in. Okay, see when you get a divide and it's maybe quite a tough one, you can't do it easily. Remember those ways we can do that. So you can take it to one side. And it'd be good to have this skill, okay, of just doing a divide. So if you get this in a non-calculator paper, and you need to do long division, okay, you'll be able to do it. Okay, so working on this skill. So I think again in National 4, looking back, in the dynamics notes that I've sent out, there's a wee brief part on it as well. So 3, does that go into 1? No. Carry the 1 over. 3 goes into 16 5 times. With 1 left over, 3 goes into 15 5 times. So you're left with 5.5. Okay, so the answer for that one is just a wee bit of complication with the decimal there. Okay, but the answer for that one, if it was a coordinate, would be 2.5, 5.5. Okay, so we've not done anything differently. It's just throwing that wee bit of complication in with the decimal. They're horrible. Okay. Another way it's been done. Sort of combining a bit of straight line knowledge. Okay, this is a past paper question that I've not written down what past paper, so I apologise, I'll try and find that. Okay, so what they do, they give you the picture. They'll say that it's 2, they'll give you a point. Okay. There's 3 parts to the question. First part,
Sorry, is that 12.5 or 12.6?
12.6.
Okay, thanks.
Prove line has equation 3y minus x equals 6. Now, when you get a proof question, okay, it doesn't change anything, but they give you the answer and you're trying to achieve that answer. Okay, but essentially you're just finding the equation of the straight line. Okay, so the equation of the straight line, and you're trying to show that it equals that. So forget for a second that they give you the answer and just imagine they've just said, find the equation of that straight line. Okay, so if they said find the equation of that straight line, what's the process you go through? Okay, so we started the class with it. We go right back to the y2 minus y1, x2 minus x1, Okay, and then you look at your 2 points. This coordinate here, you get the y value given, but that's where it cuts the y-intercept. So it's cutting the y-intercept when y is 2, x is going to be 0. So the coordinate of that is going to be 0, 2. So that can be your x1, y1. That's going to be your x2, y2. Okay. y2 minus y1 over x2 minus x1. Okay. So we've got the gradient. We've got the y-intercept, which is 2. So we can put that in. Now, remember when we did this previously, we want to eliminate that denominator. So we want to multiply both sides by what that number is. Okay, and that will cancel it out, that will remove it. Okay, so we multiply both sides. Okay, we'll get 3y, and then that whole side is multiplied by 3. So that will give us, remove that denominator, 6. Okay, so we're getting very, very close to this. Okay, we're getting very, very close to that. The last thing we need to do is just put all the letter terms on the left-hand side. Now that's going to help us anyway when we do the next part. And you'll see in a minute that it's finding an intersect with that line, okay? So moving the letter terms to the left-hand side would give us 3y minus our x equal to 6. And that has proved the initial statement. Okay, I've shown that that's the case. Okay, it's asked me to prove it. It just means find the equation of the straight line. Okay, some people get thrown off the fact that they give you the answer. Okay, but to prove it, I just need to prove that that is the correct statement. All right. Now the second part of this question in the past paper was calculate the coordinate of intersection of another line with equation 4y plus 5x okay, so calculate the coordinate of intersection of another line with equation was placed on the graph. Okay, so if we were to draw that line on it, where would the two lines cross over? Okay, so this is a simultaneous equation question. So we've got from a straight line question straight into a simultaneous equation. Okay, now really importantly, there's going to be some questions like this in your exam. Okay, usually towards the end, the more difficult ones. When you get given a proof question, very often there'll be a follow-up question like this. You don't have to actually be able to answer that proof question. Okay, you get given the answer, and the reason they give you the answer is so you can use it at a later date. Okay, so even if you haven't answered A and you get stuck at it, you can still answer B. Okay, because you still get the equation. Okay, so writing the equations down. The equation from A was 3y minus x equals 6. And the equation from 2 is your 4y plus 5x equals 46. Okay, so we're multiplying that by 5, and that's just by 1. Okay. I'm adding them. 5's eliminate each other. Becomes 76. Okay, if you get something like that, 76 divided by 19, I don't expect you to know your 19 times table, but logic dictates 76 divides by 19, okay? It doesn't simplify in any other way. So just write it down in a wee column. 19 times 2 is 38. 19, add another 19 onto that is going to be 47, 57. Add another 19 onto that is going to give you 76. Okay, 1, 2, 3, 4. Okay. Don't have to do that. It's just a wee bit of working, a wee bit of additional working. Just makes sense in my head. Okay. Substituting that in. One. All right. This time we found y. 3y minus x equals 6. 3 times 4. Now that's not the answer. So minus 6. Sorry, minus x equal minus 6 doesn't give you the answer completely. Now remember that minus x, we don't draw it or we don't write it, but you could put a wee 1 there. So it's minus 1x. So I can take that minus 1 and move that to the other side. All right, so minus 1x equals minus 6. So x, positive x. Would equal positive 6. Okay. So our coordinate would be 6, 4. All right, and if they give you a sketch, have a wee look at it and see if it makes sense. Okay, so that's a two-part question. Here using a wee bit of straight line. Okay.
Daniel, I've substituted the 4 accidentally into the 15y, take away 5x equals 30, and I've got the same answer. Would that be wrong?
No, perfect.
So I could do it like that as well?
Yep.
Okay, cool.
So you can substitute that to any of the equations you've got. All right.
Right.
They're all they all lead to the same answer.
Okay.
Okay, one more question tonight, guys, that we'll go through. And one of the ones they love with simultaneous equations is giving you a wee story. Okay. So go into a shop, 5 apples and 3 bananas. You can spell banana. Cost £1.78. Two apples and 1 banana. Cost 68 pence. Okay. Part A. Two equations. Okay, so this is what I'm saying, that the letters that we use just represent, it could be anything, it could be everyday items like apples and bananas. Two equations to represent above. Well, if we've got 5 apples, 5A, plus 3 bananas, 3B, it equals £1.78. Okay, so that's our first equation. Second equation, 2A plus 1B equals 0.68. Right, that's equations to represent above. Find the price of 1 apple, 1 banana. Okay, we're looking for the value of A and we're looking for the value of B. Okay, so it's as simple as that. So we're doing the same process. So multiply that first one by 1, multiply that bottom one by 3. Okay, 5A plus 3B. That doesn't change. Okay, 2 comes 6A plus 3B and equals 0.68 multiplied by 3. Now, you might need to take this over to one side. Why am I writing 0.68? Should be 0.64, sorry, 0.64. So 4 on one side, 0.64 multiplied by 3. Now that's just the column method of multiplication. Pretty standard way of doing sort of multiplication. Okay, so have a wee look for it and practice it. All right, it's good for non-calculator paper. So you're just multiplying each as they come, so right to left. So 4 multiplied by 3 is 13, is 12. So I'm putting the unit 2, and then that 1 carries over. 3 multiplied by 6 is 18. Oh, plus the 1 is 9. The 1 carry over. 3 times 0 is 0. But that 1's there, so £1.92. Okay. Just the column method for multiplication. Okay. Then what we're doing here, we'll minus the top from the bottom. We're getting minus A. The B's eliminate each other, and then we're getting minus what we left with 14 pence. Okay. Or 14 pence. Okay, now does that make sense? Looking at above, yeah, okay, that makes sense. So we can work with that. Okay. We're substituting that into equation 2. Okay, so 2a plus 1b equals 0. 2 apples, 14 pence each, plus a banana. Okay. Is equal to 64 pence. One banana is 64 pence minus of 28 pence. One banana with 64 minus 28 is 36 pence. One banana is 36 pence. All right. Current rate of inflation, that's pretty decent. Cost of living, isn't it? All right, so that's the type of story question. Okay, so usually values of something, or they can throw lots of things at you. Okay, so let's finish up there. Okay, but if you have a wee look at the booklet and have a wee go at these story questions. Okay, so working with simultaneous equations in context. The first two are more confusing than helpful, to be honest. All right, but from 5 onwards, these story questions are quite similar to what you might expect. All right, so there's quite a few of them to practice. All right, and then there's plenty of it. There's quite a lot. All right, so there's plenty of stuff to. Okay, so right up to page 27. So simultaneous equations. Simultaneous equations. 17 to 27. All right, but especially the story ones, try the story ones. All right, have a wee bash at them.